considering this example again, can we not do this greedily? For example, here, if I decide to move the number of steps at which I am standing at that particular stair, if I am standing at the first stair, I decide to move as many number of steps, will I get the answer? Let's check. From here I decide to take 2 steps. I took 2 steps, I came here. From here I decided to take 1 step, I came here. From here I decided to take 1 step, I came here. Was I able to do it? Yes, I was able to reach to the nth stair. Right, I was able to reach to the nth stair. But what in the scenario if this was 2? If this was 2, where will you move to? You will move here, right? It will be out of your bounds. It will be out of your bounds. But does that mean you won't be able to reach it? It will obviously mean if you can take 2 steps and you are getting the result at 1 step, is it not possible? Obviously, you won't take 2 steps. You'll just take 1 step and you'll be saying, okay, I am done. I've already reached my destination. So that is exactly what we'll do. Okay, this is exactly what we'll do. We'll consider from behind. Let's try to do this from behind. Okay, let's say this is my destination, right? Let's say this is my destination. Again, if you are able to reach from here to here, then obviously you'll be able to reach from here to here as well, right? So that's exactly what we'll do. So what we are going to do, consider this as the destination. Now from here you need to check, right? If you are able to reach from here to here and starting from all the indexes before this index, if you are starting from here and if any of it reaches this particular index, okay, if any solution reaches this particular index, then obviously you'll be able to reach to the nth stair, because you already know that from here we can reach the nth stair. So if from here you can reach the nth stair and starting from this particular index, the 0th index, you start moving and you reach this particular index from where you were able to reach the nth stair, then you can say that you have found a solution, right? Exactly. So that is exactly that we have to do. Now we'll try to code it up. We'll try to code it up and see how we can move greedily. So before moving to the code, let's do the implementation of it. So what are we going to do? We are going to say, okay, now these are the indexes, right? 0, 1, 2, 3, 4, right? These are the indexes 0, 1, 2, 3, 4. Now I say start from here. Start from this position. Okay, if you are at the last position, if you are at the last index, start from one index before that, because that is your destination, right? If you're not able to reach that, then obviously you will be not able to understand if you are reaching to that destination or not, right? So what do you have to do? You start your journey from here. Okay, you say if from here I take that index and I take the maximum number of steps. Maximum number of steps that I can take is what? It's 2, right? So if this index plus the maximum number of steps that I have at that particular stair is greater than or equal to my destination, if it is successful, if it is true, then I don't need to see, right, if any other is reaching here, if any other solution is reaching here, if any other way I can move to here. I just need to consider this now. If I'm able to reach here, then I definitely know that from here there exists a solution, right? So now what we'll do, we'll say, okay, now just check for this destination, make this as the destination. Now check, I'm able to reach from here to here, so now check if I'm able to reach here. Okay, I decide to move from here. Okay, now this is my destination and I have this here, right? From here we try again. We say, okay, from 2, from second index, if I take maximum number of steps as 1, is it equal to my or greater than the destination? Yes, it is, right? Because the destination is 3. So 2 plus 1 is greater than or equal to 3. Yes, true. So if it is true, we move to one destination before it. We need to check whether or not we'll be able to reach this destination, right? We say okay, fine, we move the destination, and now we'll check from here, right? We'll check from here. So we say okay, 1, the index that I am at, plus the maximum number of steps that I can take, that is 3. If it is greater than or equal to my destination, if it is possible, the destination currently is 2, so is 3 plus 1 greater than or equal to 2? Yes, right? So what I do, I say okay, move my destination here. Okay, I move my destination here. Now my destination is 1, right? Now my destination is 1, and I check from here, can we do this? So we say 0 plus number of steps, maximum number of steps, 2. If 0 plus 2 greater than or equal to destination, so 2 greater than or equals to 1, true. So what does this say? This says I'm able to do that. But now, can you move the destination any further? You can't, right? And can you notice one thing? The destination is now 0. It's the first element, it's the first stair. If it's the first stair, can we directly say that we have successfully reached from nth stair to 0, from the nth stair to the first stair, from nth index, from n minus 1th index to 0th index? Yes, exactly. So that is exactly what we'll do. We'll write the code for it, and it will be like better for you to understand. It's very easy. So my destination will start from where? It will start from here, right? So let's say already told, right? N is equal to the length of the array minus 1. Okay, so destination is equal to n minus 1. Now we say, starting from one index before it, for I in range n minus 2 minus 1, for I in range. Now if I plus a of I is greater than or equal to destination, so destination is equal to I. If it is greater to or equal to the destination, this index becomes the destination for the next iteration, right? So that is exactly what we'll do. In the end, we'll check if my destination has come to 0th index. If it is at the first stair, then return a true from here, otherwise return a false from here. So if you do this won't lead you to a time limit exceeded error, obviously, because what is your time complexity here? It will be O of n in this scenario, right? It will be O of n, and space complexity will be O of 1. So this is exactly what you will do, and if you submit this code, you'll be able to submit it. So we'll meet for the submission, and then we'll close this.
So guys, we'll just try to submit this code, and let's see how we can do this. So what is n is length of nums. What is our destination as according to the code? It was n minus 1, the last index. And from where do we start the loop? We start the loop from the second last index, right? So it will be n minus 2, and it'll go till the 0th index. Right now, if index plus the steps at the index is greater than equal to the destination, then destination is equal to the index. And in the end, if destination is equal to the 0th index, then you return a true, else you return a false. Let's try and run this code. Accepted. And submitted.
So guys, we'll meet again in the next video, and probably it will be a recursion problem as well. So I hope you guys have understood whatever I've taught. So yeah, We'll meet in the next video. All the best, guys.